Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. In the previous session we had completed our first chapter, that is physical world. Today we are going to start our new chapter, second chapter, that is units and measurement. We are actually starting our plus one physics journey from this chapter onwards, so listen carefully. Children, why do you study physics? Physics helps us to explain any natural phenomena going around us. So that's why we study physics. Physics is that much important. See, during a rainy season, you can see lightning and you will hear thunder. It's a natural phenomena. When I switch on the bulb or tube light, light from it falls on my face and we are able to see my face now. It's a natural phenomena, or it's a phenomena, right? And everything can be explained in physics. And to explain all this natural phenomena, we need units and measurements. So that's our second chapter, units and measurement. And today we are going to discuss some interesting facts about units and measurements. Let's get started with today's session. Children, as we discussed in our introductory video, today we are going to discuss about chapter 2, units and measurement. Children, can you see the statue on the screen? And can you identify which statue is this? Yes, it is the Statue of Unity, and it is situated in India itself. It is the tallest statue of the world. Can you give me the height of the statue? You just make a guess. Its height is about 182 meters. Okay. Now, just look at this cute baby. Can you measure the cuteness of this baby? Can you measure how cute this baby is? No, it's not possible. We can't measure the cuteness of this baby. But at the same time, we can measure the height and weight of this baby. At the same time, we can't measure how handsome or how beautiful a person is. But we can measure his height or weight. Okay, so we can't measure any expressions or qualities or emotions of persons, but at the same time we can measure certain quantities like height, weight, temperature, mass, etc. So based on this, there are two types of quantities. One is physical quantities and other one is non-physical quantities. So we are more concerned about the physical quantities in physics, and to measure these physical quantities we require what is called units. Okay, so next we are going to discuss about units. So what do you mean by units? See, in the beginning I had told you that the height of the Statue of Statue of Unity is 182 meters, right? So why it is 182 meters? Why it can't be 182 Anjali or 182 Abhay or 182 Manjeet, 182 Shreyas, 182 Wahid, like that? Because we don't know what is one Anjali. We don't know what is one Manjeet or one Abhay or one Shreyas, like that. But all of us know what is 1 meter. In fact, everyone in the world has an idea about 1 meter. So that's why we use the concept of units. So if we are speaking to a friend in US that the height of the Statue of Unity is 182 meters. So he will think, oh, 182 meters, it's a taller statue, even taller than the Burj Khalifa. Okay, so he can compare it. He can have a height of the statue, isn't it? Or when I am telling you that the Statue of Unity is very taller, I am not just talking about the height of the statue, but I am also making a comparison. Okay, so for that you just look at the statue. Can you identify this statue? See, this is the famous Buddha statue in China, which is situated in the Spring Temple in China. And the height of the statue is 126 meters. So before the Statue of Unity, this statue was considered as the biggest statue or the tallest statue in the world. Okay, so can you give me the difference between these two statues? So the height of the Statue of Unity is around 182 meters, and the height of the statue of Buddha is around 128 meters. Okay, it's 128 meter. So what is the difference between these two statues? It is around 54 meters. So that means the Statue of Unity is 54 meters taller than the statue of Buddha. Okay, so here I have compared how much taller Statue of Unity is with respect to the statue of Buddha. How much? It is around 54 meters taller. So units help us to compare between two physical quantities. So what are the two important uses of units or the concepts related to units that we had just discussed? First one is that it sets a standard. Okay, so everyone of us in the world know what is 1 meter. It's a standard. Okay, so it sets or unit sets a standard in the entire world. Also, it helps us to compare between any two physical quantities. In physics, how many physical quantities are there? Not only in physics, in science, how many physical quantities are there? Do you have any idea? There are infinite number of physical quantities in science and also in physics. So how is it possible for the layman to remember, or how is it possible for the students like you to remember all these physical quantities? It's very difficult. So scientists began to think on it, and at last they found out a solution. They have reduced down the number of physical quantities to the 7 physical quantities, and those quantities are called fundamental quantities or base quantities. Okay, and here you can see a table, and in this table the 7 physical quantities are listed. The first base quantity or the fundamental quantity is length. And what is the unit of length? Unit of length is meter, and this is the definition for 1 meter. So just go through that definition. Definition is not much important. Next, physical quantity is base quantity is mass. Unit of mass, kilogram. Next, time. Unit of time, second. Electric current. Unit of electric current is ampere. A is the symbol. Then temperature. Unit is Kelvin. K is the symbol. Amount of substance, mole, and MOL is the symbol. Luminous intensity, candela. CD is the symbol. So these are the 7 physical quantities which we consider as base quantities or fundamental quantities in physics. So what is the use of these fundamental quantities actually? So in physics, there are infinite number of physical quantities, and it's very difficult to remember all those. So scientists have reduced down the number of quantities to 7, a set of 7 quantities actually, and this set of 7 quantities form our base or fundamental quantities. So the first 3 physical quantities, that means length, mass, time. These 3 physical quantities are enough to describe any mechanics or any mechanical quantities. But when the thermodynamics came in, that when the branch thermodynamics has discovered, this temperature became an important physical quantity, and also the amount of substance which can be expressed in mole also became an important physical quantity. Okay. Now, apart from these 7 basic quantities, we have another set of quantities which is known as derived quantities. And from the name itself, what do you mean by derived quantities? Derived quantities are those quantities which can be derived from these base quantities or fundamental quantities.